Good morning, students. So today we are going to discuss another one topic of power plant engineering subject. So last class we were discussed about the gas turbine power plant, right? So today we are going to discuss the combined cycle power plant. So that is the next topic of our power plant engineering. So first, we will see the agenda of today's session. So what we are going to discuss in the combined cycle power plant. So first, we are going to the definition for combined cycle power plant. So what is mean by combined cycle? So we were discussed different cycles, right? One is called Rankine cycle, second one is called Brayton cycle. So what is Rankine cycle? What is Brayton cycle? How the applications of these two cycles used in power plants, how the power is produced, everything we were discussed in the last class. So today we are going to discuss, okay, these two cycle combined means what will happen, okay, how the power is produced. That is nothing but combined cycle. So a combined cycle is nothing but a combination of two cycle. So we were discussed different type of cycle. So in that power plant we discussed two different, one is Rankine and Brayton. So the both are combined together. Okay, that will put with help of that we can produce the power, that is called combined cycle. So that definition we are going to discuss, an introduction about combined cycle power plant. And next we are going to discuss about the basic concepts. What is the basic concept behind an Rankine cycle? What is the basic concept behind an Brayton cycle? How the cycle efficiency can be improved, and how the power is produced with help of combined cycle power plant and its working principle. All those things we are going to discuss today. So that is our today agenda of this session, right? So first we will see the definition for combined cycle power plant. Okay, combined cycle power plant are combined cycle gas turbine, a gas we can call it as a combined cycle turbine. So combined cycle power plant are also called as combined cycle turbine. So a gas turbine which is used to generate electricity, normally we can call as gas turbine power plant. And additionally, with the help of this gas turbine, we use some power producing method added with this gas turbine power plant, that is called steam turbine. Okay, with the help of that steam turbine, we can use the waste heat from the gas turbine used to make a steam to generate additional electricity via steam turbine. So that is called combined cycle. So what I am trying to say is, with the help of gas turbine, we can able to produce the power. So the outcome of that outcome or exhaust is from the gas turbine is waste heat. Okay, that heat can be utilized further to generate the steam. That steam can be used to produce for power further. So with help of these two system, that is gas turbine and steam turbine, we can able to produce more power compared with the existing method. Existing method is nothing but a steam turbine or a gas turbine is producing, okay, only little amount of power. So if you add with this, okay, with the help of steam turbine addition with your gas turbine, you can develop more power. So normally if you see in a power plant, only 33 percentage, okay, efficiency can be produced from gas turbine power plant. So remaining 67 percentage of power is went to the heat went to the exhaust. Okay, so that heat, that waste heat can be utilized further. Further, it can be produced additional amount of power with help of that heat. So with the help of steam turbine. Okay, so again the waste heat can be utilized means you can get more power. That is around initially 33 percentage only you got, but you get maximum amount we can get. You can see in the slide additional 55 percentage of power we can produce. So a normal conventional power plant getting 33 percentage electricity, but if we use a steam turbine additional with gas turbine, mean we can get up to additional 55 percentage. Okay, so you will get 68 percentage efficiency with the help of combined cycle. Okay, so that is the main advantage of a combined cycle power plant. So I ask one question to you. One is first question: which of cycle is used in a steam turbine power plant? Last class itself I asked. Okay, only few people is told the answer. I will ask
Brayons, Brayton
Danush.
cycle.
Danush. Danush.
Brayton cycle, sir.
Gas turbine. I am asking gas turbine, air pump cycle. Steam turbine.
Rankine cycle, sir.
Okay, very good. So steam cycle works based upon Rankine cycle. Gas turbine works based upon Brayton cycle. Very good. So these two cycle is combined. Okay, that will produce a combined cycle power plant. Okay. So conventional power plant, you know very well. The basic concept of conventional power plant, you know. So normally a fossil fuel, that is nothing but coal or fuel or natural gas, is normally stored in the form of chemical energy that converted into thermal energy with help of boiler due to the combustion. So what will happen? That boiler can generate the steam. That steam goes to the turbine. So mechanical energy is converted, and further mechanical energy is converted into electrical energy with help of generator. So because turbine and generator are coupled. So likewise, the chemical energy is converted into thermal energy. After the thermal energy is converted into mechanical energy, finally mechanical energy converted into electrical energy. So this is a basic concept behind on the conventional power plant. So here you can see how the coal is fired in the boiler. So water is present in the boiler is converted into steam. The steam goes to the turbine. So turbine expansion process takes place. So thrust power is generated on the turbine blade. So turbine start rotated. So generator is rotated. So power is produced. Again, the outcome of this turbine is low pressure steam. After that, it will goes to the condenser. Again, steam is converted into water. Then low pressure water is going to go to the boiler. Likewise, the cycle is continuous. So this is conventional power station. So you know very well. So what is meant by combined cycle is a combined cycle power plant produce high power output at high efficiency. I already told maximum up to 55% power we can produce uh, with a low emission. That is very important. With the emission of low, okay, we can produce maximum 55%. In a conventional power plant, we are getting 33% electricity, only 60 sorry, only, and remaining 67% is waste. So 33% electricity we can produce in a normal conventional power plant. So remaining 67% is waste. So that means it goes to the exhaust gas. That heat energy goes to the exhaust gas. So that heat energy, 67% of heat energy can be utilized, okay, with help of additional cycle. So we can produce maximum 55%. That means additionally 55% means 55 plus 30. So you got, sorry, additional 55%, maximum it gets up to 68%. So likewise, we can get the combined cycle power plant for producing the power. In US, okay, OTPC GCT power plant is one of the largest country-based gas turbine power plant, gas and steam turbine power plant. Okay, it is produced, okay, 72%. Maximum in the combined cycle power plant, we can produce, I already told 68%, but some power plant, they are producing 72%. In that, okay, the power plant have two unit, because I already told combined cycle means two cycle. One is steel, gas turbine, another one is steam. So in the gas turbine produce, okay, 232.39 megawatt, and steam turbine produce 130.91. So the power plant has two units. So maximum it produce around 363 into 2. So likewise, the power can be produced. That is 72% of power maximum we can produce with help of combined cycle power plant. So this is the combined cycle power plant. Here you can see how the construction layout is formed in a combined cycle power plant. So normally, you know, the normal fuel used in gas turbine is natural gas. So the natural gas is sent to the combustion chamber. So air is sent to your air compressor. So air is compressed. So due to high pressure and temperature, okay, the air is goes to the combustion chamber. At the same time, the natural gas fuel is entered. So both will mix it together and finally ignited. So due to that, a hot gases is produced in the combustion chamber. That hot gases goes to the gas turbine and expansion process takes place. So due to that, a generator is rotated. So with help of that, we can get one power. That is, with help of gas turbine, we can get power. Okay. Additionally, we use the steam turbine. So the waste heat that is indicated as in yellow color. So after the leaving the gas turbine, that goes to the heat recovery zone. Okay. In that, the heat is okay. In the heat recovery zone, we have a uh, water tubes. Okay, so in the water tubes, okay, passes over the hot gases. So what water gets okay heat and then finally gets converted into steam. Okay, with help of this waste heat. So that steam is goes to the again to the uh, here you can see how the steam is goes to this generator that is indicated in brown color. So automatically water is converted into steam that will goes to the steam turbine. Steam expansion process takes place in the steam turbine. So again further another one power will be generated with help of ST generator. So GT generator is nothing but gas turbine generator power generation, and ST generation we got another power. So that is steam turbine generator. So with help of this two power, we can combine this power and we will send it to the uh, power grid areas. Likewise, okay, we can develop the power. Again, the waste heat comes from your steam turbine that will goes to the condenser with help of cooling water. That's to, low pressure steam is converted into water vapor particle. Again, that water vapor is further cooled with help of cooling water. Then it will convert into low pressure water. That low pressure water is goes to your heat recovery zone. Then it will convert it into low pressure steam. And finally, again, if the hot gases is presented, okay, further it will convert into superheated steam. That superheated steam goes to a steam turbine. Then expansion process will take place. This the cycle is closed. So likewise, okay, you can get a one power from GT generator. That with help of gas turbine we can develop one power. With help of steam turbine we can get another power. So both power we can get. So maximum up to we can get 68 percentage power we can produce. So if you use only gas turbine means we can able to produce only 33 percentage of power, or we can use only steam turbine, maximum we can produce 33%. If you combine both these two uh, power plant, we can get up to 67%. In practical, some cases 72% also efficiency we can get through this power plant. Okay, so this is the idea behind on combined cycle power plant. So the combined cycle power plant consists of two following cycle. One is called Brayton cycle, second one is called Rankine cycle. Okay, so I already told Brayton cycle is used for gas turbine and Rankine cycle is used for steam turbine. So that is the one of the applications. Okay, these two cycles are applied in two different power plant. Okay, so last class itself I told how the Brayton cycle is works. This is the Brayton cycle. So the fresh air is goes to the compressor with help of the compression process. Okay, hot gases goes to the combustion chamber. So the natural gas is enter to the combustion chamber. Due to hot conditions it ignite, the combustion process takes place in the combustion chamber. So the hot gases goes to the turbine, the expansion process is takes place, so mechanical energy is produced, and the exhaust gases goes to the atmosphere. If it is a open cycle, if it is a closed cycle, means it will the same heat gas, the same loss heat gases, loss of heat gases goes to the heat recovery unit. Okay, likewise the cycle is works. So this is the PV and TS diagram. So based upon that, your Brayton Brayton cycle or your gas turbine is works. So here 1 to 2 is isentropic compression, 2 to 3 is constant pressure heat addition process, 3 to 4 isentropic expansion, and 4 to 1 constant pressure at heat rejection process. So this is about the open cycle and closed cycle Brayton cycle. So based upon that, your gas turbine is works. So if you want to increase the Brayton cycle efficiency, you were already discussed in the thermal engineering subject how the Brayton cycle efficiency can be improved. With help of 3 units added with the Brayton cycle, we can improve the efficiency of the Brayton cycle. That is, one is called intercooling, second one is called reheating, third one is called intercooling, reheating, and regeneration. These 3 systems we are already discussed in thermal engineering subject, so I don't want to repeat once again. With help of these 3 combinations, we can able to increase the Brayton cycle efficiency. So if you want to implement these 3 elements in our Brayton cycle, means the Brayton cycle efficiency is improved. That means your gas turbine power plant efficiency also improved. So whenever you want to improve your power plant, gas turbine power plant efficiency, means we have to think over these 3: intercooling, reheating, and regeneration. So by this way, we can improve the Brayton cycle. Similarly, Rankine cycle power plant operation, you know very well, with help of this 3 element. One is called boiler, second one is called turbine, third one is condenser, and fourth one is with help of feed pump, okay, cooling water pump. With help of that, the cycle is work. So that is called Rankine cycle. This is a steam by this cycle, the steam turbine is works. Okay, steam generation takes place in the coal-based thermal power plant. So likewise, the Rankine cycle power plant PV diagram operation is shown here. Here 1 to 2 is isothermal expansion process, and 2 to 3 is adiabatic expansion, and 3 to 4 isothermal compression process, and 4 to 1 is constant volume process. Likewise, okay, the Rankine cycle is works. So similarly, your 1 to 2 is nothing but your isentropic compression process takes place in the pump. Okay, so here you can see how the pump is used compressed. Okay, with help of the water. Okay, it is compressed takes place, and 2 to 3 constant pressure heat addition process in the boiler. So heat will be added. After that, the expansion process due to the boiler. Okay, the steam is generated. That steam goes to the turbine. So expansion process takes place. That is 3 to 4 isentropic expansion process, and finally the hot gases come out from your turbine that goes to the heat rejection area. With help of the condenser, it is once again it is cooled and converted into water vapor. Likewise, your Rankine cycle is works. So this is the basic concept behind on this steam turbine. So what I'm trying to say is, if we combine both 2 cycles, that is Brayton cycle and Rankine cycle, we can able to produce maximum amount of power. That is called combined cycle problem. Okay. Up to this, you have any doubt? What is meant by combined cycle? Anyone? What is meant by combined cycle?
In combined cycle, we use 2 plants, uh,
Okay.
gas and steam power plants we use. That
Okay.
is run by the application of Brayton cycle and Rankine cycle.
Very good. Okay, the combination of Rankine and Brayton cycle. So combine means with help of these 2 combination cycle, we can able to produce more power. How much power we can produce maximum? Udit, how much power maximum we can produce? How much power? Anyone? So in conventional power plant, maximum we can get up to how much percentage? Abhishek. Number 3, Abhishek. Abhishek. Abhishek, you are not responding with, I will put absent, that's all. Surya, number 71. Surya, Mohana Sundram, 55 percentage. Additional efficiency maximum up to 55 percentage. Okay, so 33 percentage we can produce conventionally. Additionally, maximum we can produce 55 percentage. Some power plant we can get up to 72 percentage. So if we combine, we can get 68 percentage, not 55, 68. Okay, right. So here next we can go to increase the power plant efficiency of a Rankine cycle. Means what we can do. So with the help of three additions, okay, we can able to improve the Rankine cycle efficiency. So Rankine cycle efficiency means if you want to improve the steam turbine efficiency, sorry, steam generation efficiency is high in the steam power plant, means we can able to improve with help of these three. One is called lowering the condenser pressure. Okay, so if you use condenser, means the condenser purpose is to convert the steam into uh, water. That is the purpose of condenser. If you maintain the pressure in low, means the steam generation pressure is low, means we can get more amount of water. That is the purpose of lowering the condenser pressure. So by this way we can improve the Rankine cycle efficiency. And second one, superheating. So if you use superheated, okay, superheated is nothing but further if you want to heat up the steam, means okay, completely the water vapor particles may be present in your steam, okay, that will fully converted into steam. Okay, so maybe due to the waste heat recovery, only some amount of water vapor particles, okay, converted into steams, maybe some particle also may be present. So that can be avoided with help of superheating device. So if you add a superheating device in the waste heat recovery system, so all the water vapor particle is converted into steam. So that steam is further converted into superheated. So more expansive process will be takes place in your turbine. So steam is normally generated only when high temperatures occur. So, but that can be achieved with help of superheating process. So by this way we can achieve the Rankine cycle efficiency more. And the third one is increasing pressure in the boiler. So if we increasing the pressure in the boiler, means automatically temperature is increased. If temperature is increasing, the steam production is also high. So that's why we have to maintain the pressure of the boiler. Okay, so that's why the boiler pressure mounting pressure regulation system also mounted in the boiler. So that's we are going to discuss later. What are the accessories, okay, involved in the boiler, how the boiler is function, everything we are going to discuss in the later portion. So now we'll think, okay, how we can improve the Rankine cycle efficiency, means by lowering the condenser pressure, by adding superheating device and increasing the boiler pressure. Okay, by this way we can improve the Rankine cycle efficiency. That means if you want to improve steam turbine efficiency, means we have to use these three techniques. I already told, if we want to increase the Brayton cycle efficiency, means we have to use three things. What is the one? One is intercooling, second one is reheating, and third one is regeneration. So with help of these three things, we can improve the uh, we can improve the Brayton cycle efficiency. And if you want to improve the Rankine cycle efficiency, we can introduce, here you can see intercooling, reheating, and regeneration. With help of that, we can improve the Brayton cycle efficiency. Similarly, if you want to increase the Rankine cycle, in lowering condenser pressure, superheating by adding superheating and boiler pressure increasing. So these three technique for Rankine, three technique for Brayton. That's you have to keep in mind. So that's all from now. Okay, you have any questions? Now you can ask. So today we discussed what is meant by combined cycle. So the combination of two cycles, how the cycles are combined together, how the power produced with help of G3 generator and ST generator, and finally the basic concept behind on two cycle. One is Brayton and second one is called Rankine cycle. And how the Brayton cycle is works, how the Rankine cycle is work. So how to improve the Brayton cycle efficiency by adding three elements. Similar way, how the Rankine cycle efficiency can be improved with the help of three techniques. All those things we discussed, right? If you have any doubt, now you can ask.
No, sir. No doubts.
சார்
Yes.
சார் செகண்டாக ரேங்கின் சைக்கிள் இருக்குல்லைங்க சார். ஸோ அதுக்கு ஹீட் சப்ளை
Yes.
பண்ணுறதுக்கு நம்ம ஆல்ரெடி ஹீட் பண்ண பேர்ன் பண்ணதுக்கப்புறம் வர ஸ்டீம் சூப்பர் ஹீட் கேஸஸ் யூஸ் பண்ணுறோம்ல சார். பிரைட் வந்து வெளியே வர கேஸ் யூஸ் பண்ணுறோம் இல்லையா சார்? அதில் ஹீட் அந்தளவுக்கு இருக்குமாங்க சார்? ஏன்னா நம்ம ரேங்கின் சைக்கிளில் வந்து பாய்லர்ஸ் யூஸ் பண்ணுவோம் அண்ட் கோல் யூஸ் பண்ணி அதுக்கு ஹீட் கொடுத்து இது பண்ணுற மாதிரி ஸ்டீம் டர்பைனுக்கு ஜென்ரலாக அந்த மாதிரி யூஸ் பண்ணும்போது இந்த இதில் ஆல்ரெடி நம்ம ஒரு டர்பைனில் ரன் பண்ணி தான் அந்த ஹீட்டே கொண்டு வரோம். பிரைட்டன் சைக்கிளில் ஒரு டர்பைனில் ரன் பண்ணி தான் அந்த ஹீட் கொண்டு வரோம். அங்கேயே நிறைய எனர்ஜி வேஸ்ட்டாக இருக்கும் இல்லையாங்க சார்? அதுக்கப்புறமா அதில் அவ்வளோ ஹீட் இருக்குமாங்க சார்?
இருக்கும் பட் அந்த அளவுக்கு ஹீட் ஜெனரேஷன் இருக்காது. தட்ஸ் வை வி ஆர் டோல்ட் நோ. ஸோ இஃப் யூ வாண்ட் டு இன்க்ரீஸ் அடிஷனல் மீன் வி ஹாவ் டு ஆட் சூப்பர் ஹீட்டிங் டிவைசஸ் போடுறோம். ஸோ சூப்பர் ஹீட்டருங்கிற ஒரு டிவைஸ் அடிஷனல் வி கேன் கெட் மோர் ஸ்டீம். ஓகே, அதர்வைஸ் ஸ்டீம் ஜென்ரேஷன் வந்து லோவாக தான் இருக்கும். ஸ்டீம் ஜென்ரேஷன் இந்த ஹீட் ரிகவரி சிஸ்டம் இஸ் வெரி லோ. ஏன்னா ஆல்ரெடி மேக்ஸிமம் அமௌண்ட் ஆஃப் ஸ்டீம் வந்து சாரி ஹாட் கேஸஸ் வச்சு நம்ம வந்து என்ன பண்றோம், ஜிடி ஜென்ரேட்டர்ல பவர் ஜென்ரேஷன் பண்ணியாச்சு. ஒன்லி இந்த வேஸ்ட் ஹீட் தான் போகுது. அந்த வேஸ்ட் ஹீட்ல இருக்கிற எனர்ஜி யூட்டிலைஸ் பண்ணி தான் ஃபர்தரா என்ன பண்ண போறோம், நம்ம ஹீட் அப் பண்றோம். ஸோ ஒன்லி லிட்டில் அமௌண்ட் ஆஃப் ஸ்டீம் தான் ஜென்ரேட் ஆகும். ஃபர்தர் இஃப் யூ வாண்ட் டு ஜென்ரேட் மோர் ஹீட்னா யூ ஹாவ் டு ஆட் சூப்பர் ஹீட்டர். ஓகே, ஸோ அடிஷனலி சூப்பர் ஹீட்டர் இஸ் ஆடட் வித் திஸ் சர்க்யூட். we can able to produce more heat. So அந்த brown colorல காமிச்சிருக்காங்க பாத்தீங்களா, அதுல only வந்து பாத்தீங்கன்னா saturated streams தான் இருக்கும். ஓகேவா, fully superheated steam இருக்காது கண்டிப்பா. So again if you want to add superheated device இதுல ஆட் பண்ணிட்டீங்கன்னா you can convert more steam. அப்போ saturated steam வந்து superheated steam convert பண்ணி that steam is goes to a steam turbine. With help of that again we can develop the power. But still saturated steam condition like if you're not adding the superheater. Okay,
yes sir, yes sir.
Any doubt? So up to maximum we covered what is meant by combined cycle. So first unit la coal பார்த்தோம், next la steam பார்த்துட்டோம், அதுக்கான basic concepts பார்த்துட்டோம், இப்போ ரெண்டு combinations பார்த்துட்டோம் and diesel engine power plant பார்த்துட்டோம். So next we are going to discuss another one topic. அது வந்து பாத்தீங்கன்னா cycle, bottoming cycle, topping cycle, in the different concepts we are going to discuss. That will be discussed tomorrow. Okay, so what is bottoming cycle, topping cycle, help of that, how we can improve the power plant efficiency. So adoda we are going to wind up the first unit, then we will move to the second unit. Okay, so up to this you have any doubt you can ask, otherwise we can leave. That's all from now. Okay.
Sir,
Udit Krishna
notes
and
first unit notes
Okay.
on sir, Google Classroom.
Okay, I will put the PPTs. Okay, up to this, what we covered, there is coal-based thermal power plant, and then a steam turbine, and combined cycle. Everything I will put it in the PPT. I will put it in the Google Classroom. Okay, then you can refer. Okay.
Okay,
I will
sir.
put the 2 mark questions in the Google Classroom. Did you refer? Nobody referred.
எஸ் சார் அந்த படிப்ஸ் மெட்டீரியல் ஒன்று இருந்துச்சு சார் பார்த்தேன் சார் அதுவும் அப்புறம் சிலபஸ்
Yes.